Right now, somewhere in the world, a factory is producing approximately 20 million paperclips. Today, just today, the world manufactures an estimated 11 billion paperclips every single year. That is more than one paperclip for every human being alive. And yet no one knows who invented it. The patent history is a mess. Multiple countries claim it. Historians still argue about it. The paperclip is possibly the most manufactured object in the world, and its own origin story is completely unresolved. Think about what a paperclip actually is for a moment. It is a single piece of wire, about 10 centimeters long, bent into a specific shape. No adhesive, no moving parts, no electronics, no fastener, just a bent wire. And that bent wire has held the world's paperwork together for over 130 years. It survives in the age of smartphones, cloud storage, and digital everything because nothing has replaced it. But how is it made? How does a coil of steel wire become 11 billion identical paperclips a year? And why did it take humanity thousands of years of metalworking to figure out something this simple? The answer is stranger. Before the paperclip, people pinned their documents together, literally, with straight pins like the ones used in sewing. You would stab a pin through a stack of papers and fold it over. It damaged the documents, drew blood occasionally, and was a constant minor annoyance of office life. For thousands of years, that was the solution: a sharp metal spike. The first patent for a bent wire paper fastener was filed in 1867 in the United States by Samuel Fay, but his design looked nothing like the paperclip we know today. It was more of a ticket holder. Then came a string of competing patents. Erlman Wright in 1877, a Norwegian inventor named Johan Voller in 1899, and an American company called Gem Manufacturing Limited in Britain in the early 1890s. Norway has long claimed Johan Voller as the paperclip's true inventor. And there is a giant paperclip statue in Oslo in his honor. When Germany occupied Norway during World War II, Norwegians wore paperclips on their lapels as a symbol of resistance, a way to show national solidarity without words. The paperclip became a national symbol of unity. The problem? Voller's patent described a paperclip that did not use a double oval loop, meaning it would not actually grip paper the way a modern paperclip does. Most historians now believe the design we actually use, the gem clip, with its distinctive double loop shape, is developed independently in Britain, and no single inventor can be definitively credited. The most ubiquitous manufactured object of the modern office has no confirmed inventor. But it simply appeared, evolved through competition and anonymous iteration, and then the entire world adopted it simultaneously. Step 1. The wire. Every paperclip starts as a coil of low-carbon steel wire, typically 0.9 to 1 millimeter in diameter. Low-carbon steel is used because it is strong enough to hold its bent shape, but flexible enough not to snap when you clip it over a stack of papers. This wire is manufactured in enormous coils, each coil containing kilometers of wire and shipped to paperclip factories. The wire itself is a product of the steelmaking process, molten steel drawn through progressively smaller dies until it reaches the precise diameter required. At this stage, the wire has no idea it is about to become a paperclip. It looks identical to wire used for coat hangers, safety pins, or bread bag ties. The only thing that makes it a paperclip is what happens in the next 30 milliseconds. Step 2. The machine that does everything in less than a second. The wire feeds into a paperclip forming machine. These machines are mechanical marvels of elegant simplicity, a series of precisely shaped pins and guides that bend the wire through the gem clip's distinctive shape in a single continuous motion. Here is what happens. In order, in approximately 30 to 40 milliseconds, the wire is fed forward to a measured length. A bending pin creates the first small loop at the end. The wire reverses direction across itself, creating the inner oval. The wire wraps around again in the opposite direction, creating the outer oval. A cutting blade severs the wire cleanly from the coil. One paperclip. Done. Modern high-speed paperclip machines produce between 150 and 450 paperclips per minute. As a single machine running 24 hours produces over 500,000 paperclips a day. The machines run continuously, fed by coil after coil of wire, with minimal human intervention. The entire forming process, from straight wire to finished double oval paperclip, involves zero heat, zero adhesive, zero welding, and zero. Step 3. Making them look like paper clips and not rust. Fresh from the forming machine, paper clips are raw steel. Steel rusts, steel scratches paper, and raw steel has burrs, tiny sharp imperfections left from cutting that catch on fabric and documents. The clips go through a tumbling process first. Thousands of clips placed inside a rotating drum with polishing media, small ceramic or steel beads that smooth out all the burrs and sharp edges through friction. Then comes the coating. Standard silver paper clips are electroplated with a thin layer of nickel or zinc, giving them the bright, uniform metallic appearance we recognize. Colored paper clips are coated in plastic, applied through a dip or spray process. The coating also serves a second purpose. It slightly increases the friction coefficient of the clip, making it grip paper more securely than bare steel would. The finish is not just aesthetic, it is functional. After coating, the clips are dried, inspected, and counted, typically by weight, then boxed in the quantities you see on the shelf. 100 clips, 200 clips. The number's so standardized that the box itself has barely changed in 80 years. Let's talk about why the paperclip is actually a design masterpiece. The Museum of Modern Art in New York, MoMA, has a paperclip in its permanent collection, not as a curiosity, as a serious example of industrial design excellence. Here is why. The paperclip solves its problem using the minimum possible material, the minimum possible manufacturing steps, and zero additional components. It does not require any tools to use. It is instantly reversible. Remove it without damaging the documents. It scales. It holds 2 sheets just as well as it holds 40. In industrial design, this is called elegance, the quality of solving a problem with nothing unnecessary. The paperclip has no unnecessary component. Remove anything and it stops working. Add nothing and it still works perfectly after 130 years. And compare it to the staple, invented around the same time. The staple is stronger, but it requires a stapler, staple remover, and permanently damages the paper. The paperclip requires nothing and leaves no mark. The economist Paul Seabright once used the paperclip as 5 facts about the paperclip that will make you look at your desk differently. Fact 1. A Canadian named Kyle McDonald traded a single red paperclip in 2005 through a chain of 14 online trades for a house, a full-size 2-story house in Saskatchewan. It took him 1 year. The trades went: paperclip to fish pen to doorknob to Coleman stove to generator to instant party to snowmobile to trip to yacht to truck to recording contract to 1 year's free rent in Phoenix, afternoon with Alice Cooper, kiss snow globe, movie role, house. The story became a book and a documentary. It started with 1 paperclip. Fact 2. The U.S. government loses an estimated $4 million worth of paperclips every year. Not through theft, but through employees using them as informal jewelry, stress toys, as in makeshift tools, and never returning them to the supply closet. The federal paperclip budget is a genuine line item in government procurement. Fact 3. NASA's engineers used paperclips during the development of early spacecraft to temporarily hold wiring harnesses during assembly, specifically because the clips left no residue, required no tools, and could be removed in seconds. The paperclip went to space as a manufacturing aid long before anything fancier was devised. Fact 4. The average paperclip contains approximately 0.5 grams of steel. The world's annual production of 11 billion clips therefore consumes around 5,500 tons of steel per year, just for paperclips. That is the equivalent weight of roughly 900 double-decker buses, entirely for a product that costs less than a penny each. Fact 5. As in the digital world, the paperclip emoji is one of the most universally recognized symbols for attachment, used across every one piece of wire, bent 3 times. No inventor anyone can name. No technology more complex than a set of bending pins. And yet, in MoMA's permanent collection, used by NASA, traded into a house, the symbol of digital attachment for 8 billion people. The paperclip didn't get famous because it was clever. It got famous because it was perfect. And perfection, it turns out, doesn't need a name attached to it. It doesn't need to be complex. It doesn't need to evolve. It just needs to be exactly right. And then last, forever. There is a paperclip on your desk right now. Pick it up, look at it, Someone figured this out over 130 years ago, and the world has never once improved on it. Every object has a file. Every material has a story. We're only just getting started. Subscribe and join us for the next one. The